restrictions on the answer that I get. That is my domain. I like to point out the domain first, and then get the answer. If my answer does not fit that domain, I have to reject it. So guys, if on the domain, to start out with log base 5 x plus 6, we already discussed this, that x plus 6 must be this, or the log does not exist. Which tells me x must be greater than negative 6. The other part, term, tells me the x plus 2, for that log to make sense, must be that, and x must be greater than negative 2. Okay? Now, when I finally solve this and get answers, if that answer, or one of those answers, or whatever I get, if it does not fit this and this, I can't use it. Okay, now to solve it. Does anyone have an idea what's going on here? To close down chapter 4. What do you see that we've already discussed that might be used here? Is all this on the left-hand side of this first example. Since I'm adding logs, could I now rewrite that as a product? And use product property. So this becomes log base 5, and the product looks like this. And of course, that's equal to 1. I hope I have this copied down correctly from your handout. Now step 2, here goes. That's product property. Yes, I'm going to, in step 2, drop the word log. That's not merely dropping it. Can someone tell me at this point, what does it mean? So again, I'm here.
5 to the 1.
5 raised to the 1 equals x plus 6 times x plus 2. Now, those of us who are sitting there and say, oh, he's dropped the log. No, I didn't. Zavia told us what it means. That's why log is dropped. She told me what it means. That's what it means. Now, this is a middle school problem. Step 3, 5 is equal to, guys, I need to expand this thing out. X squared plus 8x plus 12, save me a little time there. I think. It's a quadratic. Let's move that 5 over by subtracting. I'm going to have mine written like this, if you don't mind. X squared plus 8x plus 7. I think of factors. We're back in middle school now. X plus 7, x plus 1. Split these up. And now I have to consider for answers these two. If I have no mistake. Now, may I use them? And are they within the domain? I don't know. Maybe one might be and the other might not. I don't know. Negative 7 is negative 7 greater than a negative 6. No. Too bad. Can't use it. Negative 1 is negative 1 bigger than negative 6. Yes. Is it true? Yeah. Is negative 1 also here bigger than negative 2? Greater than negative 2. Does it satisfy both of those? So I can accept after all this work, my answer is merely negative 1. So that's my first one that I'm looking at, you guys. Does it make sense? Yeah, go ahead.
Is it x is greater than negative 2 and that's the only one you go by?
No, both of them.
Both of them?
Yeah, because look at this, same x. So whatever that value is, it's got to satisfy both.
So then you could just say it has to be negative.
Oh, no, you can put these two together if you wish. I'm just leaving separate, but it's got to satisfy both of them.
Okay, so that's how either or.
There you go.
Okay.
Okay, you guys agree? Now, I'm not going to do that. I'm going to do this with you on this one. If you wanted to do a full check, here we go. Not just looking at the domains, does it fit within the domain? If you want to do a full check, you can take negative 1 back and place it in the original. You have log base 5 of negative 1 plus 6, just replacing x by negative 1, plus log base 5 of negative 1 plus 2, I guess. should give me a one. So it's test negative one like you test all equations, go back and substitute. This becomes log base 5 of 5. This is log base 5 of 1. Guys, what is the log of 5 base 5? 1. 5 raised to what is 5? This is 1. What is log base 5 of 1? 0. 5 raised to what will give me a 1? 0. And it checks. If you want to do a full check, I just sort of looked at it to see if it's in the domain. The next one, like I said, I cannot work all these tonight. I wish I could, but not tonight. Let's call this part B. Okay, I'm going to jump down to number 3. 2 log, it's like 13 of this. Equals log base 13 4x plus 7. All that's copied out correctly. Any ideas? How would you start? Try and solve an equation. Nima.
We can take one of the logarithm to another side and solve.
Say again.
We can take one of the logarithm to another side.
Oh, you mean move it over?
Yes.
No problem. No problem, he says, Professor, won't you move the one on the right over to the left? And get a 0. There's no problem with that. Okay, then I'm gonna come back to you. Now what?
Okay. You can use quotient property for this.
Beautiful. You're subtracting 2 logs, he says that's quotient property, put this back as a quotient. I see something else I better worry about. Is I am going to use quotient, something else. How about this? Yes? Thank you. Is that Vanessa? Vanessa, thank you. She says, just move that 2, use power property back where it should be. Now if I do that with her help, we got log base 13 x plus 2 squared. Then I got log base 13 4x plus 7. Oh boy, this is an interesting one. Equals 0. Now what? I think now we want to write what, a quotient? I'm subtracting. So can I write this all together now as log base 13? You say what quotient, Professor? X plus 2 squared, that Vanessa helped me out with, all over 4x plus 7 that Nima helped me out with. Look at that. Quotient property, power property. Now, I'm going to drop log. I'm going to drop the word log. If you can tell me what this means. At this point, what does this mean? And I'm not dropping the log word just to drop it. I've got to tell me what it means. What's it mean?
13 to the power of 0.
Thank you. 13 raised to a power of 0 is equal to this strange x plus 2 what squared over 4x plus 7. What it means? And 13 raised to 0, thank goodness, is 1.
Yeah.
That does help. Now, please tell me at this point, what might you suggest I do now? We've got a lot of work going on here, but we're not quite finished. Should I cross multiply? Multiply both sides by 4x plus 7 and make it look like this. I'm running out of board space here, guys. Right over here. Now, can anyone suggest to me at this point, what might you try? across the street. Going back across the street.
Could expand out the other quadrant.
I would, so four x plus seven, as it's a middle school problem now, he says, professor, just expand this thing out. X squared plus four x plus four. That's quadratic. Let's have it. It equals 0 by moving things around. Guys, I think, oh, are you kidding? Let's see. Well, the four x's canceled? Wow, huge. And I guess if I move that 7 over, what's that, -3? Yes or no? I'm trying to come forward here. Is that what I get? At this point, is that what it is?
Yes.
And then if I try to solve this, yeah, just move the 3 over. And do a square root. Are you kidding? John, class. Here it is. This is the original. If all my work with Vanessa's help, Nema's help, all my work is correct, we're saying the answer could either be a radical 13 or a negative radical 13. You should see if it fits in the domains of these. Let me just do a quick check on one of them. So let's check radical 13. Those are strange answers. Let me check at least radical 13. Oh boy. Or not 13, radical 3. Right? Did we get radical 3?
Yeah.
You guys follow me? It is radical 3, isn't it? That's a strange answer. Boy. I've been here. And here. Good luck. Is there any other place up here that maybe I could check it besides going back to, you're supposed to always go back to the original? Yes?
Maybe you can go to like the place where you already expanded it to be not a log, where you have like,
You mean down here? Where was it?
or it's like 1 equals x squared plus 4.
Oh, down here.
Yeah.
So this is a
Something
good place and try to tolerate that radical 3 or a negative radical 3. I don't have a mistake to it. That radical 3 just surprised me too. Is it radical 3?
Yeah.
Is it plus or minus? I'm not going to do a full check on it, guys. I will do this much. You guys accept this. X plus 2, of course, gotta be that. At least I'll check out the domain. And here, 4x plus 7 must be this. X must be greater than -7/4. Now, if either one of those, radical 3 or negative radical 3, do not fit these, I mean both of them, I can't use it. Guys, radical 3 is 1 point something. Is that greater than -2?
Yes.
Is it the same time 1 point, oh, darn it, what a problem. This, is that also 1 point something greater than this?
Squared,
Is radical 3?
just barely.
No, it's a negative though, it's negative. So it's radical 3, which is positive 1 point something, does it satisfy both?
Yes.
Okay, so I'll take radical 3. Okay. Negative radical 3, teach you mathematics. Negative radical 3. That's a negative 1.7 or something like that. Is that greater than a -2?
Yeah.
And is negative radical 3, negative 1 point something, is that greater than negative, oh my goodness, 1.75?
Squared.
It does fit both?
Yes.
It does, I'll accept negative radical 3 also.
Yes.
You think it does? Now, this is the agreement on the class. Okay.
Squared,
Hang on, now you tell me this. You tell me both these will work. At least they're in the domain.
and it's gonna satisfy both domains.
Oh, yeah.
Oh, okay, before it was like.
Yeah, you got to satisfy both.
Both.
Okay, use it. Wow. Hmm. We're about to finish. I'm about to finish. Okay, one more here. Here goes. Let us see. Next one I want to look at is this one. Ln of x. Subtract 3 times square root ln of x plus 2 is equal to 0. In fact, I think I have on the handout here, at least I did. Oh, I did. This is when I usually give you a hint, like I gave you a hint, I think on one of those, a couple of these on the, exam problem. Let you be something? Okay, look at this. What might you suggest I let you be in my last example here? In an attempt to solve this thing. Square root L of x. Why? This could be rewritten like that. Let's do L of x. So this becomes what? U squared? Square 3u plus 2 is equal to 0. Barbara, is that correct? No. Is that quadratic? I think it is, isn't it? Yeah. So factors? Split this up? Mathematics. You get that? Am I finished? No, you know how U substitution works. Now you're saying square root ln of x is equal to 2. Square root ln of x is equal to 1. Now, so we'll give me an idea at this point, what would you do in the attempt to solve and get x? We've done the hard part. Now we're going to do it at the end. Square both sides. And if you square both sides here, of course, you end up with ln of x is equal to 4. If you square to eliminate that square root here, you're going to end up with ln of x is equal to 1. I'm still not finished. I don't have x. Close. It wouldn't tell me that first one, ln of x is equal to 4. What's x? I think I heard someone say. Yeah, if you tell me what it means, then we'll drop ln. We'll drop that word, ln. Does it mean base e, understood e there, to the 4th is equal to x? No. This one says e raised to what? The first? Equal to x. So you have two answers here. I'm definitely not going to check these. E to the 4th, e. I can't wait till you guys go off to university. Oh, can you imagine? And we have some great, beautiful universities. Talented professors. Research people. They've written books. Some of them teach from the book they've written. Are you going to get the same as you got here at SMC? No. Are they good? They're good. But they do it in just like an hour, you're done. And they just do it. You're copying down those as fast as you can. The hour's up, the professor's gone, you're gone. And then the next day, you're back again for maybe another hour. I mean, you don't get all this. I'll just tell you the basics. That's all they're going to do. And then leave everything else up to you. Okay, guys. Now, a student asks. Go ahead, Phil.
Sorry, I just want to ask, so what we have in the beginning, I didn't really work this out, but can we also say, so like we have ln of x minus 3 square root of ln of x. Can we convert it to minus 3 halves of ln of x? Right, because
I got you. Hang on. I got you. Good thinking. You could have. Thanks for it. Help us much. He says, Professor, could that have been written as ln of x raised to the 1/2 for the square root? Of course it could. And then he says there's a 3 out front, which by power property, if you wish, you could take it back up here, which makes this what?
3 halves.
There you go. Clever.
So we can also do that in the result.
Well, no, you could try that. I don't think I'd work that fractional base much. You could try that, but it means that. You're going to do that. Absolutely. I prefer that you read something. Now, guys, I'm going into chapter 5. I'm excited. Don't get too excited yet. Part 2. to benefit my students. Try to find and not mess this up. Some of my students are doing, there's a section of application problems. If I'm not mistaken, Caroline, you were working on those application problems. Where they mentioned something called half-life. It does not mean after this class is done, half your life is gone. No half-life in terms of science and chemistry and physics. What does half-life mean? I'll let you know what that term means, not today, but I just want to gradually, since Caroline mentioned it, there is a section of word problems that I think was on the syllabus for you to try. I would just try one simple one and then leave it, and I'm going to start chapter 5. Guys, I want to do this one. I sort of made this one up. This is an application. Here we go. A population I made this up, of 2,000 bacteria doubles in size every 3 hours. Okay, you have a colony of bacteria. It's spreading. And it doubles in size every 3 hours. Now I'd like to know the population, the size of the population maybe after a day. Maybe after a week. And see how this thing's spreading. Now with the basis of chapter 4 there, some basic facts there. I'm gonna set you up. I'm gonna let N represent the number of bacteria. Initially, right like this, N at 0 was 2,000. Watch carefully. After 3 hours, the number of bacteria, it says it's doubled. It's up to 4,000. Now, if you don't mind, lead me into this. This is the way scientists and mathematicians are. They see patterns here. I'm going to write this 2,000 as 4,000 as 2,000 times 2. What are we? 3 more hours. The number at 6 hours doubled again. We're up to 8,000. I'm going to write this as 2,000 times 4. That's 8,000. Better yet, to get a relationship point, 2,000 times 2 squared. Same thing. Let's try another. Doubles. After another 3 hours, the number at 9 hours of bacteria is now up to 16,000. We'll write this as 2,000 times 8. Better yet, 2,000 times 2 cubed. And it goes on. Now, here we go. I will tell you, of all the semesters I've shown the students is, a student, at least one student, gets the formula. Here we go, there's a pattern here. Guys, inside here is the time. So I'm going to use for my formula that I'm seeking, T for time. So I'm looking for the number of bacteria at time T. So I need a formula based on your research. Your research has shown you that. Now, can someone come up with a general formula based on what we've done through our research? And I hope I have it written down nicely so you can sort of see what's going on here. And you got it right in terms of T, time. Then you got a general formula. And after you get the general formula, I can quickly substitute in and find the number of bacteria after 24